Welcome everyone. Today we'll learn about motion in plane. This topic helps us understand how objects move in two dimensions. Physical quantities are divided into scalars and vectors. We already learned about scalar and vector in previous videos. Scalars have only magnitude such as distance, speed and time. Vector has both magnitude and direction such as displacement, velocity and acceleration. There are different types of vectors used in physics. These include position, displacement, unit, zero, equal, parallel, and antiparallel vectors. Look at the coordinate system shown in the diagram. The horizontal line is the x-axis, the vertical line is y-axis. The arrow starts from origin O and ends at point P. Point P is located at coordinates 3 and 4. This arrow is called as position vector. The position vector tells us where an object is located relative to the origin. Since the point 3 units is along x-axis and 4 units along the y-axis, the position vector is r bar equal to 3 I cap plus 4 j cap. To find the length of the vector, we use Pythagoras theorem. Magnitude equals root of 3 square plus 4 square. That gives us 5 units. So the particle is located 5 units away from the origin. Look at the graph. Point A is the starting position. After that it moves to origin, and after origin it moves to point B. Point B is the final position. The arrow connecting A to B is the displacement vector. Notice that it directly joins the 2 points. Displacement is the shortest distance from initial position to the final position with direction. Here is the particle moves from point A with coordinates 2 and 2 to point B with coordinates 5 and 6. The displacement vector is obtained by subtracting the coordinates. B minus A gives us 3 and 4. Again, the magnitude becomes 5 units. The important thing is to remember is that displacement depends only on the starting and ending positions. Observe the 3D coordinate system. The XYZ axis represent 3 perpendicular directions. The unit vector points in a direction but has length of exactly 1. A unit vector is used only to show direction. It does not represent the actual size of the vector. For any vector A, the unit vector is obtained by dividing vector with its magnitude. This process keeps the direction unchanged while making the magnitude equals to 1. For example, consider a vector A bar equals 3 I cap plus 4 j cap. To find its magnitude, we will use Pythagoras theorem equal to square root of 3 square plus 4 square equals 5. So unit vector is equal to the A bar divided by magnitude of A bar, which is equal to 3 I cap plus 4 j cap divided by 5, which is equal to 0.6 I cap plus 0.8 j cap. That's the unit vector. Look at point A. Assume the person starts from point A, moves around the path and finally returns back to point A. So the starting point and ending point are the same. The total distance traveled is not 0 because the person walked around. However, displacement becomes 0 because there is no change in the position. Therefore, the displacement vector becomes the 0 vector. A 0 vector has 0 magnitude. Now let's see equal vectors. Notice vectors A and B. They are drawn at different positions. However, they have the same length and the same direction. Vectors do not need to start from the same point to be equal. If two vectors have the same magnitude and the same direction, they are equal vectors. Let's understand parallel vectors. Look at the vectors A and B. Both arrows point in the same direction. Their line of action remain parallel. These are called parallel vectors because they act in the same direction. For example, A bar vector equal to 4 I cap and B bar equal to 10 I cap. Both point in the positive x direction. Hence, they are the parallel vectors. Now, let's see anti-parallel vectors. Observe the vector A and B. They are parallel but the point in opposite direction. Such vectors are called antiparallel vectors. Their magnitude may be equal or different, but their directions are opposite. For example, vector a bar equal to 5 I cap and b bar equal to minus 3 I cap. A point directs toward right and b points direct toward left. Hence, these vectors are antiparallel vectors. Now let's understand vector addition. Vector addition combines two vectors into a single vector called the resultant. The resultant produces the same overall effect as the original vector together. The first diagram represents the triangle law. Look at the first diagram. Vector B starts from the head of vector A. The resultant vector R is drawn from the start of A and end of B. The second diagram represents the parallelogram. Now look at the second diagram. Vector A and B from the two sides of parallelogram. The diagonal shows the resultant vector. If two vectors A and B make an angle theta between them, the resultant magnitude is R equal to square root of A square plus B square plus twice of AB cos theta. This method is used in adding forces, velocities and displacements. Now let's understand resolution of vectors. Look at the vector shown in the coordinate system. Instead of considering one slanted vector, we break into two parts. One component lies on x-axis and other component lies on y-axis. This process is called resolution of vectors. The horizontal component is ax, which is equal to a cos theta. The vertical component is ay, which is equal to a sin theta. Breaking vectors into components makes calculation easier. Notice that vector is represented using x and y components. The vector moves 3 units horizontal and 4 units vertical. So the vector can be written as a equal 3 I cap plus 4 j cap. Here I represent the horizontal direction and j represents the vertical direction. Projectile motion. Look at the picture. The object is thrown into the air. Instead of moving in straight line, it follows a curved path. This motion is called projectile motion. Whenever an object is projected and moves only under gravity, it follows a curved trajectory. In projectile motion, two independent motions occur simultaneously. Horizontally, the object moves at constant speed. Vertically, gravity continuously pulls it downward. Together, they create a parabolic path. For example, a stone is thrown horizontally from a cliff. What path will it follow? See here, this boy throws a stone from cliff. So tell me, will it move in a straight line? Will it fall vertically? Or it follows a curved path? So, the answer is the stone follows a curved path. Forward velocity keeps it moving horizontally. Gravity pulls it downward. Therefore, both motions combine to produce a curved path. Circular motion. When an object moves along a circular path, it is called as circular motion. For example, fan blades or satellite orbiting the Earth. Since relative velocity was covered in previous video, I will briefly revise it. It is the velocity of one object relative to other, and it is an important application of vectors. This is the formula of relative velocity. So, today we learn scalars and vectors, types of vectors, that is position, displacement, unit, zero, equal, parallel, anti-parallel vectors. Then projectile motion, circular motion and relative velocity.